Welcome to Lesson 7 of Module 4 Ecosystem Dynamics. In this video, we're going to be looking at the management of future ecosystems. And this, just a forewarning, is going to be quite a long video because we're going to be looking at how humans can describe some of our past ecosystems and help us to then inform our future ecosystems and helping to actually manage those. And we're going to be looking specifically at the role of humans. We're going to be looking at some models that humans can use, but also the role of climate change, which we know has changed drastically over the last 1,000 years. So anthropogenic pressure, and this is where we see uh, pressure being created due to people's ability to spread out all over the world. And this utilizes and changes the environment. Does cause some species to survive and thrive while others become displaced. This is actually, in fact, happening on a global scale. And we know from one of our previous videos, we are currently going through the sixth extinction event. And this is where we see populations soaring while many other species disappear. Due to the anthropogenic pressure caused by humans, we are in fact restricting the range of species whose population numbers and genetic diversity may eventually become so low that the species becomes extinct. So there are, in fact, there's 5 threats to biodiversity I have listed on the left, but 6 in the image on the right. And we see the threats to biodiversity as habitat destruction, invasive species, pollution, overexploitation, and climate change. And our 6th on the right is other potential threats. So habitat destruction is the leading cause of global loss of biodiversity and of species extinction. It usually occurs when human activities alter or remove the natural habitat, and therefore the organisms that previously existed there can no longer survive. The natural habitats are changed or destroyed, and it's usually to harvest resources so that the human population has food, water, energy, and a place to live. So on the right, we have some examples. So in agriculture, where we convert habitats to sustain the species of crops or livestock, things like logging, mining for oil and gas, trawling and dredging that occurs in ocean floor. We see an increase in waste disposal areas, but also the changing of outdoor spaces for recreation purposes. Biodiversity hotspots. So any region that hosts a large amount of biodiversity and also experiences a lot of habitat destruction is known as a biodiversity hotspot. And habitat destruction often occurs in the same areas as high levels of biodiversity. So the criteria of biodiversity hotspots is that they must contain at least 0.5% of the world's plant species that are listed as endemic and must have lost 70% or more of its original habitat. So here we have an image of our globe, and the red indicates all of the biodiversity hotspots around the world. Habitat fragmentation. So this is where a habitat might not be completely destroyed, but an area of the habitat is broken into smaller patches. And we see that there are dissimilar habitats that start to form in between the once large and continuous habitat. This changes the amount of habitat available, but also changes the space which can be taken up by organisms. And we see organisms no longer be able to distribute themselves within that space. And it leads to reduced connectivity throughout the habitat. This can, in fact, cause extinction, and it's due to creating smaller population size, the lack of habitat between the fragments, and this causes problems for organisms that forage over large areas. So as they're foraging, they do encounter these fragmented areas and they're no longer able to forage in that area. And edge effects cause different species compositions and abiotic factors than the middle of a habitat. So we see around the edges of these habitats, in fact, see different abiotic factors that may influence that habitat itself. Invasive species. So these species have been introduced to new areas by humans, and this can be either accidentally or deliberately. And due to the increased movement of humans across the globe due to globalization, this has enabled these species to establish in areas that they would not have been able to normally reach. It does, in fact, include pests, weeds, diseases, and parasites. So, some of the impacts that we see. So, we see increased predation to small and medium sized mammals that exist within Australia. Uh, the herbivory that they undertake causes significant land degradation. We see habitat modification, and this makes habitats more uniform and removes microhabitats that organisms do occupy. And we see changes in competition, and this is because we're creating new competitive interactions with the new native species for both food and space. So, for invaders to be successful, they in fact do have to have few enemies. They're able to rapidly grow, mature, and reproduce. They have an association with humans, either intentionally or unintentionally, and they are adaptable, especially with generalist species that can tolerate a range of environments and food sources. So the characteristics of ecosystems that do in fact make them vulnerable. So if they have space for an invader to occupy, any disturbed ecosystems are known as vulnerable, and it's because they have weakened species interactions and the population numbers of native species. Niche and resource availability. So, invasive species are successful in ecosystems with high resource availability and unoccupied niches. And then, ecosystems with moderate climate allow the ecosystems to be within a range for most species. So, it does make them vulnerable to invasive species. Overexploitation, and this is the harvesting and removal of individuals from a population faster than they can reproduce. So, due to the increases in the human population, the shrinking of habitats due to habitat destruction, and advances in technology, it means that the harvesting most wild populations is no longer sustainable. However, we do continue to harvest these populations. It's usually occurring within mammalian species, and this is mainly due to them being hunted for their fur, horns, and antlers, um, or even being trapped and traded as exotic pests. So, as these species become rarer and more restrictions as are in place, people are in fact turning to the black market, and it has caused illegal poaching. Pollution can in fact change ecosystems, and we see some chemical and physical changes caused by the pollutants. It can in fact affect nutrient cycles and does in fact cause big changes in environments and ecosystems. So, some of the examples are fertilizers that are used for crops, and we can see that leach into groundwater and flow off into waterways. Any excessive pollution by fertilizers into waterways can in fact cause overgrowth of plankton and algae. Litter and plastics pollute water and cause death among many aquatic species. Air pollution, that's in fact caused by air conditioners, pesticides, and aerosols. And then we do see acid rain sometimes being produced from pollution in the air. But climate has changed over the last 1,000 years, and it's an accumulative effect of burning fossil fuels and the production of greenhouse gases. And this does, in fact, place selection pressures on species. It can cause the climate to change by placing an overall surface warming effect on the planet, and it can in fact change the characteristics of an organism's natural habitat. So, the shift in surface temperature also does in turn cause a shift in water temperature. So, we see warmer temperatures and sea levels in fact rising. So how can we predict impacts on biodiversity? Well, by reflecting on the past and seeing the changes that have occurred within ecosystems, it doesn't help to inform society and scientists about the way we might expect future changes. This prediction allows us to take action to prevent population declines and extinctions before they occur. So, by monitoring some ecosystems, we are in fact able to infer and understand some reasons for change and also make any changes as we see fit. So, this monitoring is the process of researching and gathering information on some sort of variable. So, sometimes we monitor population size or forest cover or water quality. So, it allows the scientists to assess the state of that factor, record any changes over time, and then infer and understand the reasons for the change. Sometimes for this monitoring, we do turn to bioindicators, and these are species that are useful for monitoring changes. They can, in fact, be examined instead of the environmental conditions. This is usually more cost effective and reliable. for detecting any changes in the ecosystem, and these organisms are sensitive to change and react consistently to environmental shift. They can quickly reflect any of stresses that may be occurring in the ecosystem, and these are easy to observe and sample. So some examples that might be used as bioindicators are lichens and macroinvertebrates. We can in fact model climate change, and this is in fact important for us to understand what might happen to Earth when certain climate variables change. And most of these models are in fact mathematical models that are used to simulate climate processes and make any projections into the future. So these are the similar models used by weather forecasters to predict any future changes in the climate. And we see them run at large scales, and they're used to predict average climate conditions over time rather than the exact weather or climate on a certain day. So the global climate model uses grid cells that hold climate variable information about land, ocean, and atmosphere in that specific cell. So some of the variables that we might measure include air temperature, wind speed, carbon dioxide, any precipitation that may occur, and also vegetation cover. So we use equations to simulate change and calculate any climate variable data over a series of time. And these allow us to generate simulations for different scenarios that may occur and allow us to answer any questions that we might have depending on what humans might change or if they don't make any changes, and we can see what may happen in the future. We can also use models to measure the distribution of species, and we do in fact collect data from locations where the organisms are found, and by doing that, scientists are able to understand the niche requirements of a species. So it allows us to determine locations where a species may also be able to live outside of its geographical range in which it's might found. And this is helpful because it does allow scientists to choose reserves or restoration sites in conservation. It allows scientists to look for rare species or species whose distribution is poorly understood, and allows us to predict shifts in species distribution in response to climate change. An example of a model which we do use is in fact the Climax model that was used for the cane toad. And it was used to examine the potential spread of the cane toad under the conditions in 1990 and projected climate scenarios. So this model is used to determine the relative climatic potential of areas for population growth and the persistence of amphibians and reptiles. So we can see in 1990 on the left, we see what the average climate was like, and then on the right, we see a climate warning scenario, so any changes that may occur to the population of the cane toad. So that does include how we may predict future ecosystems. Make sure you're in class for the activities, which are really exciting for this lesson, and make sure you tune in for our final video, lesson 8.